Hello, I made a video yesterday where I compared this FlySky i6 transmitter with the new i6X transmitter, and I made a bit of a mistake in that, just judging from what they look like on the outside, I deduced that only the firmware had changed in the new i6X transmitter, and that turned out to be rather a naive mistake, because when I actually opened it up and looked inside, it is actually different. So in this video I'm going to open them both up and we'll look at them side by side and take a comparison and see what's changed in the new version. And I also want to respond to some discussion in the comments about SBUS, suggesting that instead of just saying, oh, does SBUS work? Oh, I don't know. It would be more useful if I actually gave it a try and found out so we would know for sure. So jumping right into the comparison of what's inside them, I took some pics while I had them apart, and I'll just show you them side by side. So on the left is going to be the i6, and on the right is going to be the i6X. And from this view here, we can just at a glance see a couple of differences. The first one that stands out is that there are now little circuit board pieces on the back of the switches, and there are none before. And the other big difference that I noticed straight away is that the chip here is physically larger. Because this is another thing that came up in the comments. Can you flash the i6X firmware onto the i6 and get all of those nice features that we saw yesterday? Here's a close-up of the labels that they have on them. Here's a close-up of the chips. Now, I was willing to give it a try flashing the i6X firmware onto the i6 until I saw this, and I think this is just not going to work. It's a completely different sort of chip here, isn't it? I don't know. Is this an ARM chip? I have no idea what this is, to be honest, but when I saw this I just gave up on the idea of flashing the firmware onto here and seeing if it would work. So I'm not going to do that, I'm afraid. The radio module itself seems to be exactly the same, just from looking at it from the outside. Well, should we look at things on the outside and judge them? Maybe not, but I think it's safe to say that this is the same, because the radio protocol has to be the same, given that they can bind to the same receivers and stuff. The circuit board on the new one has been given lots and lots more pads here for connecting and debugging and stuff, so you could probably put a logic analyzer on here and see what's going on with this one if you were so inclined. Here's a close-up of the switches. Electrically this is really no different, but I guess it just gives a little bit more resistance to vibration and shock, perhaps. I remember Bruce from RC Model Reviews saying something about these connections not being very secure in the long term, especially since this wire is not nice flexible silicone wire. It's just the sort of regular cheap wire. Speaking of shock and vibrations, we can see that the new transmitter has a little bit of this sticky gunky stuff stuck on some of the plug rear ends, like this here and here. Not many of them though. In fact, only these ones in the photo I think are the ones that had it. And again, you can see on the circuit board a lot more solder pads, or whatever you call these debugging connector pads. In fact, it looks like every single pin on this ribbon has been exposed. Here's a little bit more zoomed out view of the switch connections and where they go to on the main board. And in the older transmitter style, you can see that they are coming into 1, 2, 3, 4 wires for 2 switches, and they actually have a 2-position switch and a 3-position switch here. And I don't really understand how they're managing to do that with just the 4 wires. You can see that this white wire is bringing a common connection between them. So perhaps this is a ground and the other ones are floating or something, and they manage it like that. Over here you can see that they... Actually, you can't see it too well in this photo, but I'll skip to the next photo in a second and we'll be able to see it clearer. But each of the switches has its own set of 3 wires going into it. And same goes for the variable resistor there, the potentiometer at the top, that has its own set of 3 wires going in, as it did before as well. And let me just switch to the next slide so you can see it a bit better here. There's 3 wires going into each of those. And when I saw this, I got quite excited, because a while ago I actually bought, oops, we'll come to that in a minute. I actually bought some of these switches. These are 3-position switches, and physically they fit into here quite nicely. And what I wanted to do was swap this 2-position switch to be a 3-position switch, and like this. So this is already 3, but you only get one 3-position switch. And when I started using the CleanFlight iNav, which has a lot of different flight modes that I wanted to use, this 3-position switches became quite valuable, so I wanted to swap it in. But due to the way this wiring arrangement is set up, no matter which way I tried connecting up my new wannabe 3-position switch, it wouldn't work. But when I saw this, I thought, hey, it's probably going to work here because they've all been given their own separate inputs. And sure enough, if I just, I've already done this, by the way, so we have 3-position, 3-position. So this is my new switch that I put in, and it seems to be working fairly well. Oops. So we've got, this is going to be channel 8 and 9. Isn't that great? So now you could put a 3-position switch on these ones too, no doubt. Or you could put another dial on there if you had a physical way to mount it on there nicely. Or you could put 2 more switches on each of these, I guess. Or you could have a 5-position switch or whatever you want. It looks like it doesn't matter anymore. There's no restrictions caused by the way these wires are connected up. Another change I noticed on the board, probably not very important, but I just thought I'd mention it since I was taking photos. There was a debugging connector thingy on the old version, and over here there's no labels on here that I can really figure out what this is, but because this was missing and there is a similar 5-pin plug here, I'm presuming that maybe this is what that has become in the new one. And just to finish off, how about this? Isn't this interesting? Looks like a PCB antenna, this little printed line on here. So I'm guessing this might perhaps be somewhere that a Bluetooth adapter could be attached. We have ground, 3 volts and reset at the top, and then over here we have these 2 pads which connect to RX and TX. So it seems like this is some kind of a serial connection. And the only other thing I can think of on this transmitter which is related to serial connections is this plug at the back. That's a serial connection basically, and that's used for, of course, you know, using it as a instructor and a trainer, pairing 2 transmitters together. Pairing, which is what you do with Bluetooth, isn't it? So perhaps this is some kind of a way that they're going to add something here, and you can pair 2 transmitters so that you don't have to be physically connected with a wire between them when you're training a student pilot. That would be kind of neat, wouldn't it? And presumably you could also use it to connect to your computer if your computer has a Bluetooth adapter, and you could play games like FPV Freerider or something like that using this as well. I don't know, but if you have any other ideas or if anybody knows, please let us know in the comments. This is a quite interesting looking thingy here. Now about SBUS, there were a couple of requests in the comments to try SBUS, and I probably should have done that in my video yesterday. The main reason I didn't was because I thought I needed to have an inverter to change the signal coming in from the receiver to the flight controller so that the flight controller could understand it, because I've heard all about these SBUS inverters that people are using. And I took a look at the signal that was coming out of the receiver, and sure enough it changed when I changed the output mode setting from iBus, which I think this one is iBus, maybe? Not sure. Maybe this one iBus. I'm not sure. One is iBus and one is SBUS, but you can see that they're clearly different. One is active high and one is active low. But anyway, that sort of gave me the impression that there was actually an SBUS signal coming out, so I thought it was worth looking into a little bit more. And then I also discovered that in CleanFlight we have this CLI command called set SBUS inversion equals, well, on, you would use for what I'm trying to do here, so that you don't actually need an inverter, which is quite nice, provided you have an F3 or presumably F4 target. And I do actually have this board here is an F3 flight controller. I haven't used it for anything yet. I've still only been flying F1 boards for all of my other stuff. But I tried it on here, and here we go. If I just put this up here. So this is just using the regular CleanFlight configurator here. But we have roll, pitch, yaw, throttle, all the switches. So I've got the two 3-position switches there, and that one. And if we look down here, we'll see that that is in fact serial and SBUS. So there you go. SBUS does work with this transmitter. This receiver. This. It's an interesting question, because what I'm kind of hiding from you over to the left of the screen here is this. Oh, look at that. We weren't using the new X6B receiver at all. We were just using the old IA6B receiver. So how does that work? Well, I think what's going on here, what this says to me is that the SBUS signal is not being generated on the receiver, because this receiver is old. This is, if I look at the board inside, it says 2014 was when it was made. I don't think it knows anything about SBUS. Probably what's going on is the transmitter is generating the SBUS signal, sending that to the receiver, and the receiver is merely just spitting it out what it receives from the transmitter. So instead of sending like a bunch of numbers to say, 0 to 100% for this one, and then telling the receiver to encode that as SBUS or IBUS, the encoding is being done here, which is quite interesting way to do things, because it means you never really need to, you don't need to upgrade the receiver to have new protocols for your serial connections to your flight controller and so on. But does mean that you need to upgrade your transmitter. So what I said in my video yesterday now becomes a little bit wrong, because what I said at the end of the video is that the hardware is the same between this and the older transmitter, and if you already had this one, then there wasn't much point getting one of these. So I was wrong. They have done quite a bit of work inside here, upgrading things and changing things and improving things, and allowing nice little improvements like having multiple 3-position switches. Plus, because this is where the SBUS is being generated, it means that you can use SBUS on all of your old receivers that you already have. So I guess there is a reason to be buying this, especially if you are wanting to run SBUS on something. I think somebody said they're using APM, which does not support IBUS anyway. So if you're interested in SBUS, I guess it is worthwhile maybe getting one of these after all. So that's all I have to say about this for now. Sorry for making assumptions instead of looking into things a little bit deeper to begin with, but I hope that has answered some of the queries that people were having. Anyway, thanks for watching.